Hi, I'm Yafei. I do my presentation for Assignment 2, Robot Assistant Prototyping. In the study of Assessment 1, our group studied the group of disabled. Because of studies, people is unavoidably to touch the same object in government place, which may increase the risk of transmission of the virus. During the COVID-19, unstable government appeal people to comply with public health rules. Our user base is refined into visually impaired people who go to the public government place. I'm considering about how to reduce the exposure of the visually impaired, how to reduce the risk of infection when necessary contact behavior happens. So robot assistant aims to help visually impaired. According to the lecture that I researched, my robotic assistant prototyping should include these three aspects of design qualities. Voice command make it easier for visually impaired to interact with robot. Multiple languages and dialects should be supported in voice commands to improve accuracy of recognition. User feedback depending on the usage. There are a number of different feedback methods that can be used to inform the user of different stages. Touch and hearing are also most direct feedbacks that visually impaired can get. Gesture interaction is based on specific movements. Our gesture is simple and easy to learn, and more friendly to the visually impaired. Therefore, in the interaction between the blind and the robotic assistant, it's better at gesture operation and movement to the wearable device. The initial idea smart device, which have physical buttons, include volume or manuals case, and surrounding speaker. In initial design idea, I pay too much attention to voice commander and voice feedback, which lead most look like a smart sound device, but ignore the actual situation. It could not provide effective help for visually impaired, and online voice feedback was available. For iteration 1, add tile-tech feedback where vibration model and amplifying vibration and force a person body provide audio and physical feedback to the user, who use the feedback to understand the status of the robot. The important is add 5 visual sensor and the user can wear robotic assistant can on the left or right hand. The robot added with visual sensor can be better help visual impaired. When walking, the robot can scan the surrounding environment and judge whether the obstacle ahead and feedback to the user through the vibration. It can also help user read text and describe objects to reduce the number of times they touch them. However, it still does not reduce the risk of infection with necessary touch and no power button. In addition to, I improved the layout of case to reduce the cost of user learning, become more convenient and efficient. Most important thing, I decided to add the function of disaffected sprite to the robot assistant to reduce the risk of infection with necessary touch. When users need to touch objects, the robot can be used to disinfect to reduce the risk of infection. For the problems, it's like a gesture basic interaction because the efficiency may be low and it is deterable other people by playing sound outside in public. Gesture key as a final design. The idea comes from gesture port. Gestures are the natural way interaction and easier to learn and remember. Key is one of the necessary equipment of the most visually impaired when they travel alone. It helps them find the way and prevents them from falling over. I added the headphone jack at the rear and increase the gesture manipulation by reading on the key movement rather than the visual sensor. As the 5 gesture interaction include double tap, right twist, left twist, twirl, double sweep. Different gesture can correspond to different functions, which is very efficient. It shows 5 gesture movement. Some common functions can be achieved through the manipulation of gesture. They can correspond to different functions. They can combined according to the user preference. And thank you for watching, and that is my reference.